Alright, so today we're looking at the second derivative. So our learning intention is to gain the knowledge of what the second derivative is or how to calculate it. So you need to be able to do the product rule, the quotient rule, and the chain rule to a range of different functions. Okay, and you need to know the notation. So need to know the notations. Okay, so for example, we know that the first derivative, if you have f of x, taking the first derivative gives us f dash of x, or we can write it as dy over dx. We also can write it as y, if we have y, we get y dash. Okay, basically what we're going to do is going to take the first derivative and differentiate that again. So what happens to get your first derivative, differentiating the first derivative will give you f double dash of x, or y double dash, or d squared y over dx squared. Yeah, so that's probably more the formal definition. Now, if you differentiate the second derivative, you get the third derivative, all right? So you get f triple dash of x, or y triple dash, or you get this, d over dx multiplied by, so the derivative of the second derivative, d squared y over dx squared, gives you d cubed y over dx cubed. Okay, and you predominantly see people asking you for the third derivative. You may have that notation, especially in university or more complex books. They'll probably just ask you for the first and second derivative. The second and third derivative. Now, obviously, I mean, all these notations are fine. You can keep differentiating your equation until you get to a constant, and even if you differentiate a constant, you still get 0. But really, in this course and most courses, we're only going to be interested in the first, second, and third. The original function, the function that tells about the rate of change at any point, and then the third function, which basically tells us about the nature of those points. Okay. So here we go. If we got f of x equals x to the power 4 minus x cubed plus 2x squared plus x minus 7, we want to find f dash of x, and then we want to find f double dash of x, so the first and second derivative. Well, the first derivative, so bring the power down, reduce the power. Bring the power down, reduce the power. Bring the power down, reduce the power. Bring the power down. All right. Obviously, then we want to differentiate that again. 3 times 4 becomes 12x squared. That becomes minus 6x plus 4. And obviously, if you wanted to calculate, so if we wanted when x equals 3, find f3, f dash of 3, and f double dash of 3. Why not? Okay, so I've got f of 3, plugging that into my calculator. So 3 to the power of 4 minus 3 cubed plus 2 lots of 3 squared plus 3 minus 7. Oh, that didn't work. So 3 to the power of 4 minus 3 cubed plus 2 times 3 squared plus 3 minus 7. We get the number 68. If I use the first derivative, so 4 lots of 3 cubed minus 3 times 3 squared plus 4 times 3 plus 1. So I have a positive gradient at that point. So obviously the function looks like it's increasing. Let me plug it into double dash. 12 lots of 3 squared minus 6 lots of 3 plus 4. I also get 94, so it looks So it looks like the nature of that point, at that point, the rate is still increasing. It's going to continue to increase. Okay. Let's look at another example. So we want to find f of dash and f double dash if we have this. All right, so let's f of x is equal to 4x squared minus 3 lots of 4. Now, obviously, this is going to be the chain rule. So if I'm going to differentiate it once, all right, I bring the power down, and I multiply that by the differentiation of this. So that will be 8x, right? And then keep this, and the power decreases. So it works out to be 4 lots of 8 is 32x times 4x squared minus 3 cubed. Okay. And now I want to differentiate that again. So what's going to happen is I actually now have a product and chain rule. All right, so maybe I'll just use this space. If I let u equals 32x and v equals 4x squared minus 3 lots of 3, well, u dash equals 32, v dash equals 3 times 4 times 2 is 8x, 4x squared minus 3 squared, 3 lots of 8 is 24x, of 4x squared minus 3 to the power of 2. Alright, so it's a product rule, so I'm going to multiply that and add it to this. Alright, so I get 32 lots of 4x squared minus 3 cubed plus, okay, 32. The reason why I'm doing this is because I'm seeing if there's any big common factors. Times 24x squared. Okay, so I'm just taking this 32, I'm keeping that x with that x, the 24x squared that's here, and then keeping this there. And the reason why I want to do that is because this looks like a nice common factor. So I would get 32 lots of 4x squared minus 3 squared times it by 4x squared minus 3 plus 24x squared. Cleaning this up, you get 4x squared plus 24 is 28x squared minus 3. And that's a lot nicer to write than this whole thing there. Okay, so the second derivative is just differentiating again, and then obviously we can find the third derivative by differentiating the second derivative. Okay, good luck.